Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for 6.2.1. Problem number 46 is all about dilation. That's what this lesson was about. And the fact that when you dilate a figure, it either gets bigger or smaller. And the resulting figure is similar to the original. And how do we go about dilating? Well, we multiply the x and the y coordinates times the same number. And depending on what that multiplier is, the scale factor, it's either going to get bigger or it's going to get smaller. Now, here we've got three coordinates for triangle ABC. Point A is at -3, 2. Point B is at -2, -2. And point C is at +1. X is 1 and Y is 2. And if we are going to multiply the X and the Y coordinates by a scale factor or multiplier of -2, then we're essentially going to do this operation right here, where we're going to take every XY coordinate found on this triangle, and we're going to multiply the x times -2 and the y times -2. So when you multiply times any number that has an absolute value that's greater than 1, your shape is going to get bigger. Okay, if you multiply anything times 1, it's going to stay the same, and anything between 0 and 1 is going to be a fraction multiplier, which is going to result in your figure getting smaller. The fact that this is a -2 means something else is going to happen as well, but it's definitely going to get bigger. So what we're going to do is we're going to multiply the -2 times the -3 to give us 6, and the -2 times the 2 to give us -4, and we plot the new image of A here. We're going to take -2, -2, it becomes +4, +4. So here's the image of B. And then 1, 2 gets multiplied, and it becomes -2, -4, which becomes the image of C. So you'll notice something that has happened here. Every one of these side lengths is doubled in length. And this one is the easiest one to figure out. Side length AC, which is 1, 2, 3, 4 units long, becomes the image of AC, which is 8 units long. 1, 2, 3, 4, 5, 6, 7, 8. And that's ran off the graph a little bit, but that's pretty much where it's located. So every one of these, even though you don't really know the length of line AB until you learn Pythagorean theorem, this is twice as long. Okay, same thing with line CB. I'm sorry, this is the one that corresponds to AB. This corresponds to BC. So when it says describe how the triangle ABC has changed, well, the image of triangle ABC is now the side lengths are doubled, so the perimeter is going to double. So it's going to pretty much what we call double in size, although the area did not double. It's more than doubled. Another thing that you can say is it's a rotation about the origin. Here's the origin, and this is a 180-degree rotation. You could also say that it reflected over both the y-axis and the x-axis. That would be another way to describe how this red triangle is different, or how it changed from the black triangle. So doubled in size, and then there's like this inversion that takes place in a rotation around the origin. All right, what do we have here? On the same set of axes, graph the two rules shown at the right. Find the points of intersection if one or more exists. Okay, so if you did the graph, I didn't actually show the graph on here. You could have solved it using the equal values method. Remember that if y is equal to this and y is also equal to that, then this is going to be equal to that. So with that in mind, we will go through the process of moving our x's to one side of the equation. So we're going to add balance sets, and at the same time move the constant term to the other side. So our x's are all by themselves on one side, and our constant term is all by itself on this side. Okay, so 2 minus 6 is -4, and 3x's plus 1x gives us 4x's. Now we're going to use a little bit of math facts. If 4 times x is equal to -4, then that means that -4 divided by 4 will tell us what this number is going to be. And think of it this way. What would you multiply times 4 to make it -4? That would be -1, correct? And if you show the process of dividing both sides by the same number, -4 divided by 4 is -1. So that gives us our x value. But it does not give us our point of intersection. It only tells us what x is going to be at that point of intersection. So we will take this value of x and plug it into both of these equations to make sure that we get the same value for y. If we don't, then we have the wrong value for x. If we do, then we've got the solution to the system of equations. So if I say the opposite of -1, that becomes +1, and 1 plus 2 is equal to 3. And then if I take 3 times -1, that's -3 plus 6 is also equal to 3. So that proves that when x is equal to -1, y is equal to 3 for both of those equations, and that is then going to be the point of intersection of our graph and the solution to the system of equations. All right, evaluating expressions. Here's the value for x. So we've got to plug it in here, and I put parentheses around it where the x used to be. I've replaced it with its value, and now we're going to go through the order of operations. We have to take -2 and square it, so that becomes 4, and 6 times 4 is 24. Then we're going to take 3 times -2, that becomes -6, and so we'll do KFC. Instead of subtracting a -6, we'll add a +6. 24 plus 6 is 30, and then add another 1, and you get 31 for your answer. For problem number 49, this is a stoplight problem, which means that there's a common mistake. And our goal is to figure out what the mistake is, learn from that mistake, and then hopefully never make that mistake ourselves when we're solving problems. So Ms. Shreveport solved an equation in class. She checked the solution and found that it did not make the equation true, right? So if she thinks her solution is x is equal to 1/3, then you should be able to put that number here, here, and here, simplify this expression, and it'll be equal to this simplified expression over here. It didn't work. So the beauty of showing your work is that you can go back and look to see where you made a mistake and fix your mistake, not have to do the entire problem over again. So let's check. Did she do distributive property correctly? 5 times 2x is 10x, 5 times -1 is -5, and then she did not distribute it to this because the -3x is not inside the parentheses, so everything here is correct so far. Obviously, she didn't do anything here, she just brought it down. Now we have to combine like terms. If you take 10x's and you add it to this -3x's, you get some 0 pairs there, end up with 7x's minus 5, so everything there is done correctly as well. So now the last part where we add or remove balanced sets. If we want to get our x's on one side of the equation, I have to cancel out the 5x's here by adding the opposite. So 5x plus -5x is 0x's, so they cancel out. Here, that's the mistake. Should have subtracted 5x's instead of adding 5x's. So if you had subtracted the 5x's, you would have gotten 2x's, and if you had added the 5 here, instead of subtracting it, you would have gotten 14. So instead of 12x is equal to 4, it should be 2x is equal to 14. So what do you multiply times 2 to give you 14? X must be equal to 7. So now let's double check that to make sure that is absolutely correct. So if this is a 7, then this becomes 5 times 14 minus 1, which is 13. And then that's going to be a 7, so it's going to be 3 times 7 is 21. And here, 5 times 7 is 35 plus 9. So 35 plus 9 is going to be 44. So I better make sure that this is going to give me an answer of 44. What's 5 times 13? I believe that is 65. And 65 minus 21 is indeed 44. So we've just proven that our solution was 7, not 1/3. Okay, so that's the entire process that you need to be willing to go through. The copying down the problem, the showing all the work, the checking your work. If your answer doesn't check out, going back into your work and trying to see where you made your mistake. Once you fixed the mistake and then you've checked it, you've verified that you got the answer correct, now you can declare your answer. You've got to be willing to do this on every single problem that you solve to ensure that you don't make simple, careless mistakes. Okay? So be prepared. That's the kind of commitment to your work and showing your work that's going to be expected in your high school math. It's already expected now, but the math is going to get harder, so you want to make sure that you've got this ingrained in your work habits. All right, determine if the following statement below is true or false. It says justify your conclusion. It's saying this is equal to that. Well, if that were the case, then I would use distributive property, and 2 times 3 is 6. I see what they're thinking. They were thinking that that you just multiply the 2 times the 3, but when you're using distributive property, you got to multiply it times each of the terms inside the parentheses. So this becomes 6 plus 10x, not 6 plus 5x. Okay, so that is one of the reasons why I ask you to always show sending in the dive bombers, because if you don't show this step, we often forget to multiply this number times the second or third or any other term that might be in that parentheses. All right, and then the last problem, I believe, this one a little bit more complicated. I'm going to start introducing you, or not, maybe not introducing it, but reinforcing some other kinds of steps that you can use to help you figure out the rule for this data in this table. So we know we got 2, 4, 10, 28, and 6, 16. So in order for us to figure out what these other missing numbers are, we've got to find the rule. So generally, if you can find the y-intercept from the known information, it's good to write that down, and that helps you solve for the other missing parts. But in this case, they have not given us the slope, or I should say slope or growth rate, or the y-intercept for this situation. So it's going to be really hard to figure out what the rule is. So we're going to have to use our strategies. And one of those strategies that we've used a lot, especially in 7th grade, was if you've got a table here with some missing data and you see that there's a counting sequence, trying to figure out what the growth rate is in this counting sequence, okay? So if we go from 4 to 16 and we take 1, 2, 3, 4 steps to get there, that means that you're increasing by 12, and it takes you 4 steps to do that, which gives you an answer of 3, which means that our growth rate is counting by 3 every single time. And sure enough, that's what we get there. If we were to continue that all the way up to 28, this would be 19, this would be 22, this would be 25, and then 10, 28. So we've confirmed our growth rate, the value for m, is going to be 3. Okay. Now let me show you how we do this algebraically without setting up an alternate table. You can take any 2 points that you want that are known from your table. And so I chose these 2. Okay, so the value for y's, here's y1, y2, or you can go and reverse y1 and y2. This would be the x1 or the x2, depending on which direction you're going in. So if you remember this formula where you take the change in y over the change in x gives you your slope ratio. And the change in y to go from this point to this point would take 16 minus 4 is going to give you 12, which is what we got right there. Then the change in x, to go from 2 to 6, we would solve that by taking 6 minus 2, which is 4, which was the number of steps that it took us to get there when we set up this table. So now the slope ratio is going to be this simplified ratio of the change in y over the change in x. That becomes 12 over 4, which is equal to 3. So that's the number that we put in here for our rule. Now back to the table. If we want to use this table, we can go backwards and find our y-intercept, which is where x is going to be equal to 0. So I'm going to take 4 minus 3 is 1, and 1 minus 3 gives us negative 2. And then we can continue with that process if we wanted to, just going backwards, because, you know, we can confirm that that number right there is going to be negative 3, negative 11. But we're not going to go any further with that. Oh, there's our 719 right there, right? That showed up on the table. And this one should show up on the table as well, the 4 and the 10. This one and this one where we're going to have to use the rule to figure out those answers because nobody wants to create a table that big. All right, so we know that our y-intercept is going to be at negative 2. That's this number right there. But let's say we weren't using the table. How do we use this information here algebraically to figure that out? Well, we do this. We take our generic rule, y equals mx plus b. We know what our slope ratio is, or our growth rate, so we're going to plug that number in for m. We know value for x and y from our table. So do we want to take this one, or this one? Which one looks like it's the easiest one to work with? Let's choose the 2, 4. I think that one's the easiest. So x is going to be equal to 2, and y is going to be equal to 4. So now, when we solve for b, we're going to have our y-intercept. 3 times 2 is 6. And then when you subtract 6 from each side to get the b all by itself, 4 minus 6 is -2. And sure enough, that's our y-intercept. Okay? So there are many strategies that you can use to figure out the rule for this particular table. In that silent board game, doing a guess and check, figuring out the growth rates, setting up tables, using algebraic formulas, lots of different techniques that you can use to be successful with this. You just need to embrace one of them and go with it and make sure you get your answers right by checking, okay? So let's just verify. 7 times 3 is 21, and 21 minus 2 is 19. Yes, that's correct. 10 times 3 is 30, and 30 minus 2 is 28. Yes, that's correct. 3 times 6 is 18, and 18 minus 2 is 16. Yes, that is correct. We've done all the work properly. This is the rule for this situation. And I believe that's where we end today. All right, good job. How long did that take? Oops, where am I going here? Not too bad, a little bit longer than normal, but we had a few involved problems. All right, let's move on to our next activity. Take care, bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.